In this video, we're going to discuss how to solve quadratics, how to solve for the roots of quadratic functions by factoring. Let's say we have the function y is equal to x squared minus x minus 6, and we want to solve this equation for its roots. Whenever we're solving any equation for its roots, its zeros, we're just solving for its x-intercept, where that graph crosses the x-axis. Now this graph isn't necessarily the graph of the equation on the left, but it's just a graph to show that we are solving for these 2 points. To do that, whenever we solve for the x-intercept of any graph, we do that by setting the y value equal to 0, because the y-coordinate of the x-intercept of any graph is equal to 0. So 0 is equal to x squared minus x minus 6. We cannot solve it by isolating the x, because let's say we would bring the 6 to the other side. So we would do plus 6 on the right-hand side, plus 6 on the left-hand side. We would have 6 is equal to x squared minus x. But x squared and negative x are not like terms. They cannot be combined. So the next way we're going to try to solve it is by factoring. We're going to factor x squared minus x minus 6. To do that, we need to find factors of negative 6 that add up to negative 1. Factors of negative 6 are negative 1 and positive 6, 1 and negative 6, negative 2 and positive 3, or positive 2 and negative 3. The factors that add up to negative 1 are positive 2 and negative 3. So our factors are x plus 2 and x minus 3. Now we need to find some way to set this equation equal to 0. If we set x plus 2 equal to 0, then x plus 2, whatever we get for x plus 2 being equal to 0, 0 times x minus 3 will make the whole equation equal to 0. If we set x minus 3 equal to 0, then whatever we get for that, 0 times x plus 2 will make the whole equation equal to 0. So let's do that. X plus 2 is equal to 0. We're going to subtract 2 and subtract 2. X is equal to negative 2. And let's solve the other side. X minus 3 is equal to 0. Plus 3 and plus 3. X is equal to positive 3. Let's see if that's true. We're going to plug in at this step over here. Let's start with x is equal to negative 2. 0 is equal to negative 2 plus 2 times x minus 3. 0 is equal to negative 2 plus 2 is 0, so we have 0 times x minus 3, and 0 times anything is just 0, so 0 is equal to 0, and x is equal to negative 2 makes the equation true. So that one is correct. Let's try the other value for x. 0 is equal to x plus 2 times 3 minus 3. 0 is equal to x plus 2 times 3 minus 3 is just 0. And 0 is equal to x plus 2 times 0 is just 0. So the value x is equal to 3 also makes the equation true. So the two roots of y is equal to x squared minus x minus 6 are x is equal to negative 2 and x is equal to 3, and that graph would cross the x-axis at x is equal to negative 2 and x is equal to 3. Let's look at one last problem. Y is equal to 2x squared minus 5x minus 3. We want to solve this equation for its roots, for its x-intercept. So to do that, we're going to set y equal to 0. 0 is equal to 2x squared minus 5x minus 3. Now, we can't solve this by isolating the x, because if we would add 3 to both sides of the equation, we would have 3 is equal to 2x squared minus 5x. And since 2x squared and negative 5x are not like terms, they cannot be combined. So to solve this, we're going to use factoring. To factor the right-hand side of this equation, we're going to have to use factoring by grouping, because a, the coefficient of the x squared term, is greater than 1. So to do factoring by grouping, we're going to multiply the A term by the C term. We're going to multiply 2 by -3, and that's -6. And then we need to find factors of -6 that add up to -5. Factors of -6 are -1 and +6, +1 and -6, -2 and +3, +2 and -3. The factors that add up to -5 are +1 and -6. So we're going to rewrite our equation as 0 is equal to 2x squared plus 1x minus 6x minus 3. And we're going to, because -5x is the same thing as plus 1x minus 6x. If you don't remember this, you could look back on the videos on factoring by grouping. We're going to divide this equation in the middle and use GCF to factor both sides of the equation. The GCF on the left-hand side is x. If we divide 2x squared by x, we're left with 2x. If we divide 1x by x, we're left with 1. The GCF, we bring down the sign before the first number on the right-hand side. The GCF on this side is 3. -6x divided by -3 is 2x. -3 divided by -3 is +1. We're going to rewrite our equation as 0 is equal to the factor from the parentheses, which is 2x plus 1, times the factor that's not in the parentheses, which is x minus 3. Now we're up to actually solving. We just rewrote the question in factor form. Now we're up to actually solving this quadratic equation. We want to solve for what would make this equation equal to 0. Well, if we set the 2x plus 1 term equal to 0, then 0 times x minus 3 would make the whole equation equal to 0. If we set x minus 3 equal to 0, then 2x plus 1 times 0 would make the whole equation equal to 0. So let's do that. 2x plus 1 is equal to 0. We want to get the x alone. Minus 1 minus 1. 2x is equal to -1. Divide by 2, divide by 2. X is equal to -1 over 2. This is one value for x. Let's solve the other side. X minus 3 is equal to 0. Plus 3 and plus 3. X is equal to 3. That means that this parabola would cross the x-axis at x is equal to -1 over 2 and at x is equal to 3. Let's see if that's true. We're going to plug in our values back at this step. We'll start with x is equal to -1 over 2. 0 is equal to 2 times -1 over 2 plus 1 times x minus 3. 0 is equal to 2 times -1 over 2 is -1. -1 plus 1 is 0. 0 is equal to 0 times x minus 3. 0 times x minus 3 is just 0, so 0 is equal to 0. And the value x is equal to -1 over 2 makes the equation correct. Let's try the other value. 0 is equal to 2x plus 1 times 3 minus 3. 0 is equal to 2x plus 1 times 3 minus 3, which is just 0. 0 is equal to 2x plus 1 times 0 is just 0. Since the value 3x equals 3 makes the equation correct, x is equal to 3 is a correct solution to this equation.